I didn't ask what type of function is it. Okay, I'm going to ask now. What type of function is it? Anyone?
It's a rational.
Thank you. It has, it's rational because it has x in the denominator. Remember we said that last time. 1/2 x is not a rational. This is basically a linear function. It's 0.5x. So if it doesn't have x in the denominator, it's not rational. Okay, so let's say, Nabitha, can you tell us the domain of this function?
All real numbers except 1.
Excellent. Well done. Thank you. Of course, x minus 1 cannot be 0, which means x cannot be 1. So indeed, the domain is written as negative infinity 1 union 1 to infinity. And yes, please get used to this table. We're going to add to it a lot of stuff later. So negative infinity to infinity, 0 has to be in the table always, even if the function is undefined at 0. And then under 1, I don't have anything to write. If you don't like this thick bar, just write undefined or whatever you feel comfortable with. So what do we know about a function like this one, rational, when it's undefined? What happens there? Not always, but in this case.
There's going to be a hole in the graph.
Okay, very good. So let's talk about that. When a rational function is undefined at x equals a number, any number, then one of the two possibilities will be encountered. Number 1, vertical. Anyone?
Asymptote.
Thank you. And the second possibility, as you said, and that opens a Pandora box, because now, since you mentioned that, then I have to show 2 different things. Okay. So in this particular case, can I further simplify this function? What about Gia? What do you think, Gia?
Sorry, I was muted.
That's okay. Can I further simplify this function?
No.
Of course not. Since I cannot simplify in any way, shape, or form, x equals 1 is a VA, for sure. So this is an example of vertical asymptote. But now, since you mentioned the hole, which I was going to get to later, but that's perfect timing anyway, a hole in the graph of a rational function, we are talking about rational functions, will look like this. A function that is, let's say, x plus 2 over x plus 2, x minus 3, has 2 restrictions. Okay, Gabriel, can you tell us the restrictions?
It'll be 2 and 3. Oh, wait. Yeah, 2 and 3.
One more time.
2 and 3.
One more time.
Oh, wait. Can you hear me?
Yes.
Oh, I said 2 and 3.
Yes, but that's not correct.
Wait, sorry, negative 2.
I completely agree. Only after we state the restriction, not before, we have to simplify the function. So this function can be simplified. Okay, so then Lindsay, what is the simplified form? Lindsay, you're muted.
Sorry, I was talking. I was muted. It would be x equals 3.
The simplified form.
or just the x minus 3 equals,
The simplified form, one more time.
Would it be 1 over
Excellent. Very good. Okay, so as you see, this factor stays, which means x equals 3 will be if the factor stays. Derek.
Sorry?
If the factor stays, what does x equal 3 represent?
Oh, asymptote.
Of course, thank you. What will the factor that disappears represent? What will this represent?
A whole.
Yes. Can anyone give us the point that represents the whole? And how we determine it? Jordan, are you with us?
Yes. Would it be 1 over -5? Do you plug it into the x, the simplified version?
So, but x has to be -2.
Yeah, so I'm trying to figure out why.
Okay.
So it would be -2, comma, so if you plug it back in.
Exactly, you said it.
So
Indeed.
-1/5.
Yes, I agree. So in the simplified form, I will plug in -2. I get -5, so this is -1 over 5. Is everyone okay? Everyone? Any questions? Okay, I got a thumbs up. I will continue. So coming back to our function, yes, I have to plug in 0. Can Kellen tell us what is the x-intercept? I meant the y, of course. When x is 0, what is the y-intercept?
It is -1.
Very good. Awesome. Can anyone tell us where this function is going? Like the end behavior. Where is it going? In other words, if I replace x with a very big positive or negative number, where will 1 over 10 million go? 1 over 10 million.
It will go to 0.
Thank you. The same thing. Which also means y equals 0. Anyone remembers? Paul? I'm sorry, Trey. I read your note.
Would be the horizontal asymptote.
Thank you very much. Very much. Thank you. Now, one more last step. I need to know where the function is going here and here. So it's about time for me to share my screen and show you a different way of determining that. Very easy. We don't have to. We don't have to use the calculator for this whatsoever. But let me just show you how to do it with a calculator. Of course, you have to plug in the function. And you can say, well, I can graph the function. And if I graph the function, I already know the behavior left and right. That's fine too. But instead, I just want to clear this. Please remember, every time you plug in a function with expression in the numerator, expression in the denominator, if you do not put parentheses, you're going to get a totally different situation. Okay? So now I go to second and table. And of course, if I plug in 0, I get, I'm sorry, of course, if I plug in 1, as we know, I get error. But I don't want to plug in 1. I want to plug in something very close to 1. Like, for example, 0.99. Why isn't this working? So please go first to second and table set and change the independent variable in ask mode. So scroll down to the right, press enter, and now it will allow, the calculator will allow us to plug in the numbers we want. And now second and table, And now I will plug in 0.999, which is from the left of 1. And I want to plug in 1.0001, which is very close to 1, but on the right of 1. As you see, the left gives us a negative number, the right gives us a positive number. Of course, they are big in absolute value, and that is the behavior of the function near the vertical asymptote. Behavior of the function near the vertical asymptote. Negative infinity on the left and positive infinity on the right. That is all we need to know. I would like to make sense of this information that's perfectly clear, from 0 down to -1, further down to negative infinity, from positive infinity down to 0. And now we're ready to graph. Are we? Javon, are you ready?
Yeah.
Good. Okay, so when we graph a function with asymptotes, we graph what first? Jordan.
You should graph asymptotes first.
Yes. Thank you very much. The asymptotes are not part of the graph, so they will not be graphed as solid lines. There are two asymptotes, one at x equals 1, and the other one at 0. This is an overkill. There is no need. Why it's an overkill? Because it's the x-axis. So there is no need to do that. At this point, I know 0, -1. I don't care. You can determine 10 more points if you want. There is no need. From approaching 0 asymptotically, crossing the y-axis at 0, -1, and going down to negative infinity. That's what the table is telling me. From approaching 0, it's not a straight line. Don't graph it as a straight line. It doesn't touch the asymptotes. So make sure it doesn't touch your asymptotes. And then on the other side, from positive infinity to 0 asymptotically. And this is our graph of f of x equals 1 over x minus 1. We're going to do this again in a later chapter with more complicated situations. Now, as I mentioned, I would like to talk about arctangent. So now, moving forward, I would like you to remember how a rational function looks like. Moving forward, the simplest possible rational function is 1 over x. Here it is. And we have to remember this. Every time we talk about the function f of x, 1 over x, we have to have this graph in our minds. Okay? And of course, this is a right shift of this graph of 1. So here's the vertical asymptote, here's the horizontal asymptote. The graph is shifted 1 to the right. So please remember, this is to remember. Okay, next one. I want to talk about the arctangent. So f of x equals arctangent. What does arctangent mean, and is there another way of writing arctangent? Let's say India, give it a shot. Is there another way of writing arctangent, and what does it mean?
I don't know.
That's okay. Oscar, are you with us?
Yes, but I'm not gonna try.
Okay, anyone would like to try? It's okay.
Is it? Oh, go ahead.
You could write it as tangent -1 of x, like raised to -1 power, yeah. And that means inverse of tangent.
So it's okay to say I don't know on a topic, But next time we talk about it, it will not be okay to say I don't know. It's okay to say I don't know. And I want you to say I don't know honestly so I know what I need to address. Any questions? So careful with this. We have, yeah, I don't want to, maybe I should just go back. Let me share my screen again. Here it is. So as you see, we have sine inverse, cosine inverse, and tangent inverse in the graphing calculator. Tangent inverse, and they all are activated with, so if you go to y equals and clear, so I'm not going to graph it till I graph it by hand first with you. But for example, this is the inverse function of sine is not 1 divided by sine. Okay, so this is the inverse function. It's applied to numbers and it will return angles. The same thing with inverse of cosine. Same thing with inverse of tangent. It is applied to numbers and returns angles. So let's come back here for a second. So arctangent, it's always easier for me to write than this, especially when I type, right? So it doesn't matter. They are the same. So tangent is applied to an angle and gives us the output, a number. But tangent inverse is applied to a number and returns an angle. And this is true for all inverse functions and all trig functions. So tangent or sine of an angle is a number, sine inverse of a number is an angle. Okay, this is a widely used function, and you will see you will encounter it in limits and all over the place. So I would like to graph it with you. I'm not going to go through point by point, but I would like you to remember the graph. Like I'm kindly asking you to remember this one. I will ask you to remember the arctangent. And I will ask you to remember the exponential e to the x and the log, natural log x, in a moment. Okay, so does anyone remember function tangent? Does it have restrictions? And now I can dig up, because last time you had a brilliant question. And I said here, tangent, it's a ratio. Because it's a ratio, will have restrictions every time its denominator is 0. Anyone remembers when is tangent 0?